Going to be this is just a video for problem number 2. I did do a live stream of it earlier. It went super well. The people who were involved in the live stream asked really good questions and things like that. But I did have some issues with the live stream kind of cutting in and cutting out. So I did need to kind of re-record this and throw it on YouTube so that I could kind of have a good version of this. So unfortunately, you won't get the benefit of some of the questions they were asking, but I will go through this. Again, I do encourage you to, I'm going to be live streaming again tomorrow. I do encourage you at 10 a.m. To join the live stream. It was pretty useful. I thought that the people who the feedback that I got was after we got fixed some of those technical issues that they seemed to appreciate it. So again, please feel free if you're available at 10 and you want to join the live stream. That would be useful because you can ask your questions and things like that. Anyway, let us move on. So I'm going to look at this question here and let's see what we got. So the graph of f is shown to consist of a semicircle and these lines. And then we define g of x by this function. So the very first thing was, as talked about yesterday, is when they give us a graph, we need to decide what is it. Is it a position function, a velocity function, or acceleration? I think you guys would agree this function is g prime of x. It is the velocity or it is the derivative of g. So we are looking at a derivative function when we look at that, and that is important. Okay, that being said, let's go and see what we can do here. So the first thing we want to do in A is I want to find g of 0. Well, g of 0, notice the way they define things. So, right, g of x equals this function. So in other words, g of 0 equals the function, the integral from -3 to 0 of f of t dt. And remember, when we were first talking about integrals, what does that represent? That definite integral represents the area from either the positive or negative area from the curve to the x-axis. So if we're looking at -3 to 0, we're actually looking at what is the area of that purple trapezoid. And that purple trapezoid is 1/2 the average of the bases times the height. So base 1 would be this, base 2 would be that, and then the height would be that. So in other words, it's going to be equal to 1/2 the average of the bases, so 2 plus 1 times the height, which is 3. So this is 9/2. Okay, and then moving on, we're going to go find g prime of 0. G prime of 0 is going to be f of 0, right? Again, based on our function. So in this case, let me erase all this stuff here. G of 0, looking at the graph, is this point right here. So it is 1. Okay, let's move on to question B. Find all the x intervals on, find all the values of x, can't read, in the open interval from -5 to 4 at which g attains a relative maximum. Okay, so this is very similar to a problem we did yesterday. I'm going to make a quick sign chart. Again, the sign chart, you can't use it for a justification. They are asking us to justify. The sign chart is just for me. So because the reason I'm making a sign chart is, remember, minimums and maximums occur where the derivative equals 0. So in other words, since let me erase this really quickly, then I'll come back. Since g prime of x equals would be equal to this, right? And by second fundamental theorem of calculus, this is just going to be equal to this, as we saw before. Now, the reason I emphasize this is we're looking at, so in other words, I'm looking at this derivative, and first off, this is all, it's not really needed as part of I'm just kind of explaining to you guys. So what's really needed here is I need to go and find those values. So I'm going to go make a sign chart, and I'm going to look at my graph. So my graph has critical numbers, either where the derivative equals 0 or where it's undefined. So they don't tell us that this thing's undefined, so it equals 0. I think you guys would agree here, here, and here. So we have critical points at x equals -4, x equals 1, x equals 1, 2, 3. X equals 3. Okay, let's look at x equals -4. To the left of -4, notice graph lies below the x-axis. So the derivative, so our derivative is negative. Then to the right of -4, it is above the x-axis. So it is positive. Now let's look to the right of 1. To the right of 1, above the x-axis. So it's positive. And that remains true all the way till it gets to 3. And then at x equals 3, to the right of x equals 3, it dips down to negative. So what does that tell us? It tells us that we have a relative minimum at -4, some sort of stall at x equals 1, and a relative maximum at 3. So what was the question? The question is asking us at which point is g attain a relative maximum. So I think you guys agree that is at x equals 3. So I would say at x equals 3, there is a maximum. There is a relative maximum. The reason I know that, because let's see here. Because let's see. I'm trying to think of a good way of phrasing this. Let's see. Because G prime, which equals f, changes from, let's see. So at x equals, what did I say, -4, it changes from decreasing, because it's negative, decreasing to increasing at that value. So a couple quick notes. The language, increasing, decreasing, those are derivative words. So again, so I'm talking about G, and I'm saying, hey, or I'm sorry, I'm talking about G prime. So in this case, when hold on one second. Let me just make sure I'm saying that correctly. I'm not correct. Let me scratch that. I didn't say that correctly. So I'm gonna erase that. I did not say that correctly. So the reason I didn't say that correctly was let's start over.